To do Bayesian data analysis effectively with a team, it's important to have good tools to manage a collaborative workflow. In this video, I'll introduce you to two tools, Git and GitHub, that we will use in this course. My goal is to convey a general idea of what these tools are and why they are useful, and then I'll go into more detail about how to set them up and use them in other videos. So, Git and GitHub are two components of a collaborative version control system. So, in order to understand what they are, you have to understand what a version control system is. So, this is actually a practice that comes out of software engineering, but has really become useful in any kind of work involving code or even, non-code kinds of documents. So a version control system is basically just some kind of system that tracks changes to a project. So who made the change, what they did, when they made it, and if they put in a good enough message, why they made it. And it allows earlier versions of a project to be recovered, and it keeps the history, and it allows collaborative changes to files. So just to give uh, an example, let's say you have a project that's going on over time, and at some point, Joe says, "Oh, I created the README file," and then, Teresa goes in and edits it, and she makes her report. And then, Angela decides, okay, she's going to go in and add the logo. And so they're all working on the same files and they're all keeping track of what's going on together. So why should you consider using a version control system, especially if you're not a software engineer, which I am not? The main reason is that it helps team members work independently together. So oftentimes with Bayesian data analysis, for example, you have multiple people who are working toward the same goal, but they really need to, focus and work independently and then connect to figure out, who's doing what and check in on their progress. So a version control system helps you do that and also helps you work together on the same files. And it's useful for teams because it tells you who did what when, which is an opportunity for you to be individually recognized for your work on a team project. And for a manager, it can be a good tool when you're thinking about promotion decisions, um, that, you know, might be a little bit careerist, but, when you're early in your career, it's nice to have an opportunity to advance. Um, and version control, of course, especially if you're developing some kind of software, is really helpful when something goes wrong and you can't figure out why, you can always revert to a previous version. So just to give you an example, let's say, we're on our project timeline, we've made our README file, edited it, added a logo, maybe you figured out, oh, whoops, the wrong logo, and you can just revert that commit and make a new commit, and it's like it never happened. That's a scenario that's fairly rare, but is a benefit. So one important concept. So I've mentioned that Git and GitHub are mostly useful for teamwork, but in science especially, your most important collaborator or teammate is probably going to be yourself in the future. So I've often had to put projects down for months at a time while I wait for peer review or funding decision, or maybe a collaborator is supposed to do some piece and then I'm supposed to pick it up where I left off. So having a version control system is really helpful because it shows like what you were thinking the last time you touched this project and really is good for picking up where you left off. So circling back to Git and GitHub, oh, wrong direction. So Git is a version control software that you install on your computer. It's very lightweight, does not take up a lot of space. And GitHub is a cloud-based collaboration platform that works with Git. So similar to the way RStudio works with R, though the analogy isn't quite complete. But GitHub also has a lot of tools for helping collaborative workflows that are independent of Git, including tools for making websites and publishing your code. And so they are really helpful to use together. Git is a free open source software similar to R. GitHub is free to use, but it's not open source. Has paid upgrades available depending on your needs. But for this course and probably most of your research career, you probably won't need any of the paid options. So there's a lot more to these tools, which we'll get more into as we learn how to use them. So motivations for using Git and GitHub. So, they're not the only version control systems out there, um, but they are free to use and they're lightweight. As I mentioned, they're easy to install, don't take up a lot of room. They're user friendly, especially a lot of the software that people have developed to work with Git and GitHub. And there's a lot of educational resources. This link is in the descriptions to the GitHub documentation. There's all kinds of instructions on how to get started and what all the words mean. It's just a big learning community similar to the R learning community. And lastly, it's just really widely used across many sectors and countries. It's if a group is using a version control system, it's most likely to be Git and GitHub. So, since you're having to learn a lot of new tools for this course, you might help to see how they all fit together. At least I find that helpful. So I made this little diagram. Um, so this is your computer, and you have these three programs installed on your computer: RStudio, um, R, and Git. And then GitHub is this cloud-based server that you interact with through the internet. And RStudio is basically the only software that you actually interact with on a day-to-day basis. All of this stuff is going on in the background. So RStudio has just user interface for doing version control with Git. And that's why I think it's useful and helpful to learn these tools early on because it's really a big benefit with very little added effort. The hardest part is just getting it all installed and wrapping your head around the concepts, but it's once you get started, it's super easy to do and very worthwhile. So I hope you think that it's worthwhile for you. Um, but Git and GitHub can be a little intimidating to new users because there's a lot of jargon. There's even a glossary on the GitHub page that I refer to sometimes when I get lost. I put that link in the description. I'm just going to introduce you to two terms right now. I think for other terms, it's easier to understand them as you use them. So, a repository is a collection of files and folders for a given project. So there are two kinds of repositories. The local repository is just a folder that lives on your computer, and a remote repository is a folder that lives on a web server that you access through a URL. So this and this will be the same set of files and folders, but it's when you're programming, it's often a lot more convenient to interact with files locally rather than having to download and upload everything. And the Git software helps to coordinate changes between these two endpoints. And then a commit is just a record of a change to the repository. And I put that at asterisk there that there's a caveat that we'll get into later where Git might ignore some stuff. But generally, if you make a significant change, you will make a commit, which comes with a message. So in this example, each one of these speech bubbles is the commit message, and it corresponds to whatever this person did in the project and what files they created, saved, deleted, whatever. So those are the two core terms that will come up. There will be many more, but we'll get to those as we go through the workflow. So yes, arrows. All right, next steps. You'll be I'm recording another video to show you how to set up Git and GitHub within our studio and just get it started. And then just another video to practice version control with our studio just to get a sense of the day-to-day mechanics. So I hope this was helpful, and I hope the next videos will be too.